In this demonstration, I am taking water that's in a beaker, and it has a thermometer in it, and it's going to be placed in something called a vacuum chamber. So as I pan back out here, you're going to see that I've connected that apparatus to a vacuum pump, which is going to pump out the air molecules. Avogadro's law states pressure, or at least the volume, decreases with the number of particles, but as we lower the number of gas particles in the container, I'm going to lower the pressure. So what I'm trying to do is, and I'll put the top back on and seal it here. What I'm going to try to do is take out the gas molecules. I'm going to try to lower the pressure above the liquid. We know the liquid right now is evaporating because it does have molecules that have enough energy to overcome the attractive forces between them. And we know it's evaporating, but at a low rate. And we're trying to get boiling here. We're trying to boil water at room temperature. You can read the thermometer is about 23 or so. Hard to read through the glass chamber, but it's about 23. And we're going to try to boil this water at room temperature, about 23 degrees Celsius, by lowering the atmospheric pressure. That's all I'm trying to do here. Because we know that boiling is when the atmospheric pressure upward, which is the gas molecules escaping into the gas phase, equal the atmospheric pressure pushing down. When those two forces are equal, we get boiling. So when you say the boiling point of water, it can be any temperature. So I'm trying to prove that. So let me turn on the vacuum pump, lower the pressure, and right now this water is evaporating. It is going from a liquid phase to a gas phase right now. We don't see it because you can't see steam, but it's not boiling because the atmospheric pressure is too large. So we're going to lower the atmospheric pressure right now. And I'm pulling out the gas molecules, and once I drive out all the gas molecules, there'll be less molecules to collide with the surface, less force pushing down the surface, and I should achieve a maximum rate of evaporation called boiling. So you can actually see it starting to happen now, and there's our boiling. Now I want you to take careful, look at the temperature of the system. It's actually falling a little bit. And you may say, well, why is the temperature dropping? We're boiling at 22 degrees Celsius, 21 degrees Celsius. Very interesting. How can we boil at 21 degrees Celsius? Because boiling is when the atmospheric pressure equals the vapor pressure. And at 21 degrees Celsius, we're producing a low amount of air pressure. Well, if I have low force or atmospheric pressure pushing down, we've got boiling. If you look carefully, though, the temperature is dropping. The temperature is getting colder. The water is getting colder as it boils. Very strange. Okay? Now why can that be? It's really just below 20 now. Well, remember, very important. Evaporation or boiling is an endothermic process. We're not applying any heat here. Where is the energy coming from to make this water boil? It's coming from with the water within. So the water is losing the molecules that are moving the fastest are leaving as gas molecules because of the lowered force or lowest atmospheric pressure. So therefore, the molecules that are left are the slow moving ones. That's why the temperature is dropping. If I had a stronger vacuum pump, and there's some good examples of this on YouTube, we could actually make this freeze. Okay? I'll shut this down, but you can see clearly the temperature drop. Why? Because we're losing the higher end molecules to the gas phase. Therefore, the slower numbers, the best analogy I can give you is that you have a class that has an average of 80 in the class. And you take out your top performers, your top people, the people earning the 90s, and I pull them out of the class. What happens to the average? The average drops. And my friends, that's what's happening here. The average kinetic energy is dropping because the faster molecules are moving. Therefore, we have a colder water. So it's a pretty interesting phenomenon. Boiling water, and it's getting colder. Now, I'm going to stop this, increase the pressure, and maybe, just maybe, I can make this freeze. So now I'm down to about 16 or 15 degrees Celsius. More than I expected. Okay, so I'm going to stop this now. Alright, and we made water boil at 15 degrees Celsius. What I'm going to do now is I'm going to let the pressure back in and see what happens. Okay, I don't think I saw any freezing. but let's see if we can read that thermometer any better. Okay, so the energy that was used to boil, okay, is being used, and that it got pretty cold. So if we look at our thermometer, we're still about 14 degrees Celsius. So we were at 23 and we're down to 14. That showed us how much energy the water lost to the evaporation. Remember, evaporation boiling is an endothermic process. The environment gets colder.